Bidding on energy-efficient homes with foam-insulated exterior walls presents unique challenges for electrical contractors. Primary difficulty lies in the construction method, which often involves a thick layer of foam sandwiched between two layers of plywood. This creates a confined space that makes running non-metallic sheath cable, commonly known as NM cable, more difficult than in standard construction. Firstly, cutting holes through the thick foam insulation can be time-consuming. The density of the foam requires specialized tools and techniques to create clean and appropriately sized openings for wiring. Secondly, the narrow space between the plywood and foam makes maneuvering the NM cable challenging. The limited space restricts movement and requires careful planning to avoid damaging the cable. Thirdly, NM cable is susceptible to bending and kinking if not handled carefully. These kinks can compromise the cable's insulation and create potential safety hazards. To account for these challenges when bidding on an energy-efficient home, consider applying a difficulty factor to your normal pricing. A factor of 1.5 is a reasonable starting point, but this may need to be adjusted based on the specific characteristics of the project. This difficulty factor compensates for the increased time and effort required for, firstly, cutting through the foam insulation. Secondly, carefully maneuvering the NM cable through tight spaces. And thirdly, ensuring the NM cable is properly secured and not kinked. It's important to use specialized tools to minimize damage to the foam insulation. A sharp utility knife or foam saw can create clean cuts without compressing or tearing the material. Consider using cable protectors or fish tape to guide the NM cable through the wall cavities. These tools can help to prevent kinking and protect the cable from abrasion. Secure the NM cable properly to prevent movement and potential damage. Staple the cable to the studs or joists, ensuring that the staples are not too tight, which could damage the insulation. If an NM cable proves too difficult to maneuver, explore alternative wiring methods. Armored cable or flexible conduit may provide a more robust and flexible solution for navigating the tight spaces. Always communicate with the homeowner about potential delays or additional costs associated with the unique construction of the energy-efficient home. Transparency and clear communication can help to manage expectations and avoid misunderstandings. Here's an example of how to calculate the modified price for a receptacle in an energy-efficient home. If your normal price for a receptacle is $50, the modified price would be $50 multiplied by the 1.5 difficulty factor, which equals $75 per receptacle. Remember that this is just an estimate and actual prices may vary depending on factors such as the size, complexity, and location of the project. It is essential to provide accurate and detailed bids to ensure fair compensation for your work. When working with NM cable, always adhere to the National Electrical Code, also known as NEC. Ensure that the cable is sized appropriately for the intended load and that it is properly protected from physical damage. Pay close attention to the bending radius of the NM cable to avoid kinking or damaging the insulation. The NEC specifies minimum bending radii for different cable sizes. When stapling NM cable, use insulated staples designed for this purpose. These staples prevent damage to the cable's insulation and provide a secure hold. Be mindful of dirting factors when running multiple NM cables together. The NEC specifies dirting requirements to prevent overheating and ensure safe operation. When using alternative wiring methods such as armored cable or flexible conduit, follow the manufacturer's instructions and the NEC guidelines for installation and termination. Armored cable requires special connectors to ensure a secure and grounded connection. Flexible conduit requires appropriate fittings to maintain its integrity and protect the conductors inside. When cutting through the foam insulation, be careful not to damage any existing wiring or plumbing. Use a stud finder or other locating tools to identify the location of these utilities before cutting. If you encounter any obstacles, such as pipes or wires, adjust your plan accordingly to avoid damaging them. Always disconnect the power before working on any electrical circuits. Use a voltage tester to verify that the circuit is energized before proceeding. Wear appropriate personal protective equipment, including safety glasses, gloves, and hearing protection. Working with power tools and electrical wiring can be hazardous, so it is important to take precautions to protect yourself. If you are not comfortable working with electrical wiring, hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to ensure that it is done safely and correctly. Obtain any necessary permits before starting any electrical work. Permits ensure that the work is inspected and complies with local building codes. Keep accurate records of all electrical work performed, including wiring diagrams and material specifications. These records can be helpful for future maintenance and troubleshooting. When working on an energy-efficient home, be aware of the potential for air leakage. Seal any penetrations in the walls or ceilings to prevent air from escaping. This will help to maintain the home's energy efficiency and reduce energy costs. Consider using energy-efficient lighting and appliances to further reduce energy consumption. LED lighting and Energy Star appliances can save significant amounts of energy over their lifespan. Educate the homeowner about energy-efficient practices and technologies. This can help them to make informed decisions about their energy usage and reduce their environmental impact. When installing receptacles, choose tamper-resistant receptacles, also known as TRR. These receptacles have a built-in safety mechanism that prevents children from inserting objects into the slots. Ground fault circuit interrupter, also known as GFCI, protection is required in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCI receptacles protect against electrical shock by interrupting the circuit when a ground fault is detected. Arc fault circuit interrupter, also known as SI protection, is required in many areas of the home. SI breakers protect against electrical fires by detecting arc faults, which are a common cause of electrical fires. Use wire connectors that are appropriate for the size and type of wires being connected. Wire connectors provide a secure and reliable connection and prevent wires from coming loose. When splicing wires, make sure to use proper splicing techniques. Poor splices can create a fire hazard. Label all circuits clearly at the electrical panel. This makes it easier to identify and troubleshoot circuits in the future. Keep the electrical panel clean and organized. This makes it easier to inspect and maintain the electrical system. Regularly inspect the electrical system for any signs of damage or wear. This includes checking for frayed wires, loose connections, and damaged components. Replace any damaged components immediately. Electrical systems can deteriorate over time, so it is important to perform regular maintenance to ensure safety and reliability. Consider having a qualified electrician perform a comprehensive inspection of the electrical system every few years. This can help to identify potential problems before they become serious. Stay up to date on the latest electrical codes and standards. Electrical codes are constantly evolving to improve safety and efficiency. Attend continuing education courses or workshops to stay informed about new technologies and best practices. Share your knowledge and experience with others in the electrical industry. This helps to promote safety and professionalism. Remember that electrical work can be dangerous, so it is important to take precautions and follow all safety guidelines. If you are not comfortable working with electrical wiring, hire a qualified electrician to perform the work. By following these tips, you can safely and effectively bid on and complete electrical work in energy-efficient homes with foam-insulated exterior walls. These homes present unique challenges, but with careful planning, proper tools, and attention to detail, you can ensure a safe and successful project. In addition to the points already discussed, consider the following aspects when bidding on and wiring energy-efficient homes. Firstly, determine the specific type of foam insulation used in the walls. Different types of foam have different densities and thermal properties, which can affect the ease of cutting and the potential for air leakage. Secondly, investigate the presence of any vapor barriers or air barriers in the wall assembly. These barriers can affect the placement of electrical boxes and the routing of wiring. Thirdly, assess the accessibility of the wiring pathways. In some cases, it may be necessary to create access panels or channels to facilitate wiring installation. Fourthly, consider the impact of the insulation on the heat dissipation of electrical components. Ensure that electrical boxes and fixtures are adequately ventilated to prevent overheating. Fifthly, take into account the potential for condensation within the wall assembly. Proper sealing and ventilation can help to prevent moisture buildup and protect the wiring and insulation. Sixthly, evaluate the compatibility of the wiring materials with the foam insulation. Some types of foam can react with certain wiring materials, causing corrosion or degradation. Seventhly, consider the potential for electromagnetic interference, also known as EMI, from nearby appliances or equipment. Shielded wiring may be necessary in some cases to minimize interference. Eighthly, plan the wiring layout carefully to minimize the number of penetrations in the insulation. Each penetration creates a potential pathway for air leakage. Ninthly, use sealant or caulk to seal any penetrations in the insulation around wiring and electrical boxes. This helps to prevent air leakage and maintain the integrity of the insulation. Tenthly, test the wiring thoroughly after installation to ensure that it is functioning properly and that there are no electrical faults. This includes checking for proper grounding, polarity, and insulation resistance. 11thly, provide the homeowner with a detailed wiring diagram and a list of all electrical components used in the project. This information can be helpful for future maintenance and troubleshooting. 12thly, offer the homeowner training on the operation and maintenance of the electrical system. This can help them to understand how to use the system safely and efficiently. 13thly, follow up with the homeowner after the project is completed to ensure that they are satisfied with the work. This demonstrates your commitment to quality and customer service. By considering these additional factors, you can provide a comprehensive and professional electrical service for energy-efficient homes with foam-insulated exterior walls. This will help to ensure that the homes are safe, efficient, and comfortable for their occupants. Remember that continuous learning and adaptation are essential in the electrical industry. Stay informed about new technologies, best practices, and code requirements to provide the best possible service to your client.